got something that looks like this. And this is where we had 1/2. Actually, it's going to go opposite way. Opposite way is wrong. Opposite way. That's better because I was positive and then I was negative, wasn't I? Yeah. Okay. We knew that this here was when t equals 1/2. So we knew that we were moving in a positive direction for 1/4 of a second. And if we measured this on our calculator and we did our function to find out the integral, well, you'd get 1/4 here. And here it would tell you -1/4. So what you've done is essentially found out the displacement. You've cancelled these two out, saying, you know what? I've just had the same space that I've done before. If we put into your calculator, if you went into your calculator and wrote y in the y equals function and put the absolute function of 1 minus 2t, what would happen here is if we graphed this again, is it would stop here and bounce back up. So when t is equal to 1/2, we've got 1/4, and when t equals 1, we've got another 1/4. And what this does is it adds up the positive values. It makes anything that's negative positive. So therefore, we get a total area of 1/4 plus 1/4, which equals 1/2 centimeters. That's another way you can use your graphics calculator to be able to calculate that answer. The second way is, again, looking at what we're doing in terms of integration. So, if we looked at this here, we know that we worked out when t is equal to 1/2, we've got a root there. So we can work out from from 1/2 to 0, we have a function that we can actually work out. Then we also have another function from 1 to 1/2. Because we're trying to work out that once it hits the root, it's changing back. So we work out the integral for this part, and then we work out the integral for this. However, because it's the rule says that we have to subtract them, you end up getting a double negative here. And that double negative, because it's below the x-axis, you have to put that negative into it to turn into a positive. By using the absolute value function, we bypass that. Okay, so we know that it's going to be positive straight up. So what we do here is, if we put the absolute value around it, it instantly turns this into a positive number. So therefore you're adding it to it. So let's look at the algebra and see if we do get that, that answer. So we've got 1/2. Was it 1/2? I think, yeah. Yeah, 1/2 to 0, wasn't it? Yep. 1/2 to 0, 1 minus 2t dt plus the absolute value of 1 to 1/2, 1 minus 2t dt. And what's good about this here is you integrate one, the other side's going to be exactly the same. We've already integrated this, so we know that we're going to have t minus t squared 1/2 to 0 plus t minus t squared 1 to 1/2. So when we're looking at this part here, let's plug everything in. We know we're going to have 1/2 minus 1/2 squared. Alright, if we minus 0 from that, it's going to make no difference. Plus 1 minus 1 squared, let's break it around here, minus, and we already know we're going to have this part here, 1/2 minus 1/2 squared. And what we get in this case is we get 1/4 plus 1/4 is equal to 1/2 centimeters. So we do actually get that exact same answer. So what have we done? We've looked at an example in terms of finding the total distance travelled and the displacement using the velocity function and the displacement function. We looked at it in terms of using a motion diagram. And when we had all those C's over, that was only using 3 types of C's. Sometimes you can get up to 4 if you've got more than one turning point. And they can get confusing with all those lots of C's. And what that did is all that working out, yeah, there's nothing wrong with that working out. But we had to do that extra work to find out, well, how far was it actually traveling, okay? The displacement wasn't too much. But when it comes to distance, remember we said in that last video that the velocity function in integration is measuring that distance. So if we have that in terms of what we know of integration, using the absolute value function or using the graphics calculator, we can actually get that exact answer. It looks like it's a little bit more work there, but it's something that you're used to. You've done it already when it's come to indefinite integrals. Okay? Nothing wrong with doing either end. It's up to you which one you choose. But I would prefer the more algebraic method because it takes you straight to where you're going. You're using what you're used to and you're not introducing that new idea of the motion diagram. But remember, the motion diagram is good for a visual cue. But graphing the velocity function also gives that same information. Remember, if you're moving right, it's positive. If you're moving up, it's positive. If you're moving to the left or down, it's negative. And that's what we had in our graph when we looked at it. On the top, it was positive. On the bottom, it was negative. And when we looked at our motion diagram, to the right was positive, to the left was negative. All right. I hope you enjoyed that. I hope it made sense. We are going to look at velocity and acceleration in the next video. See you then.